We've determined now that this center pivot irrigation system is a profitable investment if our assumptions hold. Remember, we made some heroic assumptions about additional revenues that we would get and additional costs and how much we could sell the irrigation system for in 3 years. If all of those were true, then this would be a good investment. But are we guaranteed of all that, of those net returns? And the answer is no. So now we want to do some sensitivity analysis. And as I've said before, the net present value in and of itself isn't all that meaningful. We need to do the analysis behind it, and that's what we're getting into now with the sensitivity analysis. The question that I'm going to pose to introduce this topic is, how sensitive is this investment to our assumption of additional revenues? How does a change in revenue affect the profitability? Obviously, if the revenues go down, the profitability goes down, but to a point that it makes this no longer a good investment, we don't know yet. Or we can pose the question, what is the least additional operating receipts the farmer could earn from this investment each year and still have it be a profitable investment, holding everything else constant? We assumed, if I recall, that this farmer was going to increase his revenues by $20,000. And if he did, it was going to be a profitable investment. Well, what if he only got $15,000 additional revenue? Would it still be a good investment? Or $16,000 or $17,000? Where's the break even? At what point, if the revenues drop below a certain point, will it no longer be a good investment? Okay, first of all, let's look at how does a change in revenue affect profitability. The measure of profitability that we're going to use is the net present value. We've already determined that net present value is the profit over our cost of capital, or our cost of required return. We're going to calculate the net present value then as a function of operating revenue. If you think about it, that makes sense. If we want to know how profitability is affected by the operating revenue, we want a function where net present value is a function of the operating revenue. And then we can graph the net present value over a relevant range of values for the operating receipts. Then we can get a feel for how dependent profitability is on that variable. Pulling back the worksheet that we had to calculate the net present value for the irrigation system, we see that we can write the net present value in notational form, where we have the initial cost, we have the present value of the after-tax net returns, we have the present value of the tax savings from depreciation, and we have the present value of the after-tax terminal value. When we calculated the net present value initially, we plugged in the numbers into this equation. We did the arithmetic, and the net present value was at 165. I've repeated those equations at the top of this slide, and we've started again with each of the variables for the net present value. But notice in this equation that we've duplicated this equation that I've just circled on this last line. But the difference is, notice that for the net returns, I've left that as an unknown variable. We're assuming everything else is constant except for the operating receipts. The operating receipts, if you recall, is part of that variable of net returns. Remember that net returns is this operating revenue minus your operating expenses. So in this particular case, what we are doing is we're substituting in this equation for the net returns. Now we also know from the problem, we're assuming that the operating expenses were $4,000. By substituting in appropriately for the values, we now have net present value equal to a function of the operating receipts or operating revenues. We're trying to find the sensitivity to profitability to our assumptions on operating receipts. Now we have set the profitability equation, which is the net present value, as a function of operating receipts. Now the nice thing is, and that's why we've set this problem up in the component method, to answer this question, we can substitute in directly from our original net present value equation for the three components. The fourth component is one of the unknown variables. So we pull this equation from the bottom of the last screen to the top of this slide, and we see that we have the net present value as a function of operating receipts, which we wanted, but notice that we still have this USPV factor. So we have to have a value for that factor. Now you can remember or go back to your notes and know that this is 1 minus 1 plus r to the nth power over r. Okay, I mean you can go ahead and plug those numbers into that and you can get the answer. Or I'm going to show you another trick or technique that you can use when you need to calculate those factors. Remember that the present value of a uniform series looks like the equation that's now on the screen. If we set the annuity to 1, it happens then that the USPV factor is actually equal to the present value, as you can see by this equation. And then to solve for this, we simply put in the 3N, the 10% I, put in a 1 for the payment, zero out the future value, we compute the present value, and that present value of 2.4869 is equal to that factor. So that's the value of your factor. We're going to take that 2.48 and replace it here for the USPV factor. Now we basically do the arithmetic, and we have the net present value then neatly and compactly stated as a function of the operating receipts. Now you can go in, and if you have 19,000, if you assume 19,000 is your operating receipts, your net present value actually goes negative. If you use 20,000 and plug it in, it's 165. And then if you choose 21,000, the net present value jumps to 2,100. Simply substituting in different assumptions about operating receipts. We can actually plot this on a graph, where on the vertical axis we have the net present value, and on the horizontal axis we have operating receipts. And you can see from our graph on the previous table we have 19,000, 20,000, and 21,000 with the appropriate level of net present value. And we just plot it. And because this is linear, you only need 2 points actually, and then you have your line. Okay, the sensitivity of the investment to a variable can be measured by the steepness of the slope, negative or positive. For example, looking at this particular problem, if this had been a very flat curve so that it looked like this, would a change in operating receipts affected the net present value very much? A change wouldn't have made much difference. What if the line looked like this? What if it was very steep? Then a slight change in this from here to here, notice it has a huge impact on your profitability. You have to look at the steepness of that slope. You can see visually that the steepness is important. Now in this particular case, looking at the break-even point, again, you can see the break-even point is somewhere where that crosses the zero axis, where net present value is equal to 0. Same thing that we did with the internal rate of return, now we're doing it for operating receipts. Now to find that break-even point, the break-even, looking at the margin of error, what is the least additional operating receipts the farmer could earn from the investment each year and still have a profitable investment, holding everything else constant? Now you saw from the graph that it's something a little less than $20,000. To actually calculate that, we can use the equation that we set up before, where net present value was a function of the operating receipts. We set net present value equal to 0, and we solve for the operating receipts. Then we can compare the estimated additional revenues with the break-even amount. Okay? If that break-even is very close to what we estimated, you know that this is very sensitive. If not much room for error, then it's very sensitive. In this particular case, the break-even, you see, it takes place just a little less than $20,000, and you're assuming $20,000, you don't have any room for error. It's very sensitive. And if sensitive, you need to be sure your estimate is accurate. For example, in this particular case, where we set the net present value equal to 0 and we solve for OR, we find that it's 19,917. In this particular case, where we're assuming 20,000, and if it drops below less than $100 than what you determined and it's no longer a profitable investment, that gives you a strong signal that you better be sure of that $20,000 additional revenue. You got to go out and check your numbers. You have no room for error. Now, if that break-even amount had been $4,000 and you estimate it's going to be $20,000, are you going to worry much about that number? If this is profitable with just additional $4,000, are you going to worry about that number when you're pretty sure you can get $20,000? No. But in this case, you have to be, because you have less than $100 error in those numbers. In this particular case, if you're looking at the estimated OR and the break-even, you only have an $83 wiggle room. So we can be very clear that in this particular case, it's very sensitive. That means that you have to go out and spend some time collecting information on that variable to make sure that this is going to be a good investment, and make sure that you're not just assuming that you can get $20,000 extra in revenue so you can justify this investment. As it turns out, you can check the sensitivity of any variable. The net present value is broken out by its particular components. You can choose and look for the sensitivity to the initial cost, embedded in the net returns, the different prices, the different costs, the different revenues. You can check the marginal tax rate, and you can check, obviously, the discount rate, which we've done. You could look at the different forms of depreciation that the Uncle Sam allows. You can check your terminal value. You can check on any of the variables contained in the net present value. And you can ask, how does a change in any of these variables affect profitability? And you can look at the steepness of the slope. And you also want to look at the margin of error. That is, how does the break-even compare to your projected value? If they're very close, then you can assume that this is very sensitive. If there's quite a distance, if you've got a large margin of error, you don't have to worry so much about it.